The Sustainable Engineering Alliance has arrived at Microelectronics UK 2025. And we have the World Made Better podcast team with me today. So I'm John, behind the camera is Max, and organising everything is Michelle. And we're going to be charging around the show, up and down the aisles, dropping onto people's stands and quizzing them about the sustainability aspects of the semiconductor industry. Our focus in this particular sector is often on power and energy consumption. Semiconductors are ubiquitous in most electronic products these days, and thus we're talking about volume components going into volume products, which means that a fraction of an improvement in energy efficiency can have a huge impact on energy consumption and resource consumption worldwide. So we're going to be talking to engineers today to find out what technologies they're deploying in the design and manufacture of their components to make sure that energy efficiency is a top priority. Right, we are now on the Lumico stand, and I stopped here because there's a machine doing things, and we like to go and have a look and talk about machines doing things. Practical example of some advanced engineering in operation. So I'm here with Stephen, co-founder of Lumico Digital, and Stephen is going to talk us through what this machine is, what it does, some of its attributes, and things like reliability, right first time, that type of thing. Over to you, Stephen.
So this is part of our automated storage and retrieval system that we've developed for a customer that's based in the hard drive industry. So this particular unit here is actually part of a much larger system that we developed that actually is on the television in the background at the moment. So this unit itself is actually about 2 meters wide, 4 meters high, goes into goes into factories that are based in Southeast Asia. With this kind of stuff, getting it right first time is really, really important. Predominantly, the customer has got very little time to waste when they're trying to make use of these systems. So this optimizes the product flow on the back end of their systems or of their manufacturing flow, which essentially allows them to ship product faster to customer. So this will be after the hard drive test has actually happened. They'll store the hard drives in here and then they'll recall them at a particular point in the future so that they can ship out all the time, reducing work in progress. In terms of the sort of stuff that we engineer here, it's really important that it's reliable for the client. If we can't get them anything that's reliable, they're not going to use it, essentially. So from design, manufacture, production, and into the factory, this actually was a 9-month project, which is almost unheard of in the industry with how fast we were able to turn it around.
One final question. I'm just wondering how additive manufacturing and 3D print is kind of making its way into this type of special purpose machinery. I'm guessing it would be quite helpful with kind of tooling and jigs and prototyping, that sort of thing.
Yep.
Is it something that you guys are working with? Where are you on that?
Sure. Yes, it is something that we work with, mainly because it allows us to turn something around very quickly for prototyping with a lot reduced amount of wastage, essentially. So as an actual example of that, yesterday we've got a vision system that we're integrating into a new product. We needed a jig in order to actually be able to fix that to the product. Now, that would have taken possibly weeks to turn around before. Now we're able to design it. We were able to 3D print it in-house with our equipment that we actually have. And that was then, within 3 or 4 hours, we could actually test to see if that was okay.
Right.
With the files that we can then get produced, we can then possibly farm that out if we needed to make it into either plastic or metal or whatever it was. But essentially, low wastage, fast turnaround, great for prototyping. We think it's great.
We are on the Advantech stand, and I am with Darren, who is the Sales Director Embedded IoT, UK and Ireland. And what caught my attention was this product here, which is a computer on module, Qualcomm products. And one of the attributes of this, I'm talking to Darren, is low power operation but high performance. We can see it here on a carrier board. And interestingly, the applications are now reaching into the industrial sector for robots, drones, AMR, automated mobile robots. So what we're going to do now, hand over to Darren, give us a talk through about this and the relationship with Qualcomm, where it's going to find the technology in the marketplace.
Yeah, sure. So what we've seen here is Advantech are partnered with a lot of silicon vendors. Qualcomm is a new one that we're launching a set of products for. focus, as you say, is really on low power and a reasonable amount of AI performance. So this one in particular is up to about 12 tops. Right. So for mobile applications, you can get a fair bit of good work for processing power on low power. Right. To make it easy, it comes in a very small form factor. The customer would normally design their own carrier board. This is a development board, so you can get up and running and test the application very quickly. But they would normally design their own carrier board with their own connectors on there, their own footprint, and then obviously lay the CPU module down on top so they can build their product really quickly. To aid that, we have a development kit which will get everybody up and running. And the beauty of this setup at the minute is it combines both Windows 11 support and also Ubuntu from a Linux support. Yep. So depending on the application, you'll be able to use either or. Yep. And from the Ubuntu support point of view, we obviously use our partner Canonical, who will provide the license and a 10-year critical support. Okay. So matching the sort of Microsoft Windows support that you get for 10 years, which is perfect for industrial applications. Yep. And also then, as you said, for the mobile applications that are on the marketplace right now.
Brilliant. Excellent. Thank you very much for that introduction. Obviously, from a sustainability perspective, with the mobile applications, they're going to be battery powered probably. So we're looking at electrification. For electrification and mobile applications, you need low power, so you can minimize the batteries and get the maximum run time. Hence the low power the interest we have it looking at from there. And interestingly, also with the software support there for 10 years, another aspect there which is longevity. The idea that a system can be designed and put into the market and expected to work for, I think you said 10 years on the software support.
I think for industrial computing, 10 years, 7 to 10 years is what people are looking for from a silicon point of view. So you have the same service and support that you can for your product. Right. If you're changing the hardware every 2 years, it's a little bit of a difficult thing to do and to support in the market. So yeah, definitely longevity is key.
Yeah. And what would our audience do if they wanted to get involved in this technology? What's the checklist?
Well, first is understanding what their application is, what they're trying to achieve from their application, and what they need potentially to make it work. Then they can reach out to Advantech, we can discuss in detail, and we'll find a solution, whether it's the Qualcomm board here or one of our many other boards over there on the back wall. We have a variety, a huge portfolio of products, a huge portfolio of whole partners as well. So yeah, reach out and give me a call.
We are now on the M2MGubbins stand, and the reason that we stopped here was something caught my eye, which is modules. Now, why do we like modules at the Sustainable Engineering Alliance? We like it because it helps companies design and manufacture and test prototypes as fast as possible with minimum waste. So with a modular system such as this for IoT type products, you don't have to start designing, manufacturing and discarding PCBs during that development process. All you need to do is go to an array of modular components, bolt them together, test them, develop the software, and then ultimately when the prototype is looking good, it can then be migrated across to a final product with the support of this company. So I thought it was also worth having a look at this. It's a wonderful indication of the kind of hardware modularity that can go into a product like this. It's including power supplies, displays, enclosures, HMI, etc., etc. There's an array of the products here. So the idea is efficiency in the design process, i.e. right first time. So there's no worry about developing a product that would fail at ultimate test or need to be reworked in any way. Because of the array of components, there's the option to work through all of the component elements in an IoT system. And as I mentioned, once that prototype is then confirmed as what the end application needs, it can then be migrated across to a finished product with the support of this organization to then take it to market. So a nice example of right first time, quick time to market, minimal waste, maximum performance, right first time. The Blueshift memory stand, and we're with Helen Duncan, who is the CEO. And the reason we stopped on this stand was this poster here, which is showing a 90% reduction in energy consumption. Imagine this technology applied in data centers. With the abundance of data centers and their energy requirements, it could have a significant impact on the sustainability of those installations. So the big question is, what is it and how does it work and what comes next? So I'm going to hand over to Helen, who's going to explain exactly what it is, how it works, and what the roadmap is for rollout.
We're addressing two problems. One of them is the so-called memory wall, which is the fact that memory technology hasn't kept up with the advances in processor technology. And the result of that is that the processor actually sits there for something like 80% of the time waiting for the data that it needs. The other problem is the energy wall, which is that data centers in particular are becoming unsustainable. They're consuming more and more energy. It's not a particularly well-known fact. It takes 1,000 times more energy to move data from the memory than it does to actually process it. So our technology, which is patented, an innovative new computer architecture, structures the data in the memory so that we know where the data is and we only bring it across when it's needed. We reduce unnecessary data transfers across the bus. By doing that, we reduce the wasted energy. There's a knock-on effect as well, of course, in data centers, because you have to use additional energy to cool the data centers when all that heat is produced. 2/3 of the energy consumption in data centers is from the DRAM and the core, and we can reduce both of those to a total of around 90% reduction in energy consumption.
Tell us, where are you on the roadmap of this technology? If an engineer likes the sound of this, wants to get involved, wants to start testing this technology, where are you and what should they do next?
Okay, at the moment we are working with a Taiwanese memory company, AP Memory, who are originally a spin out from PowerChip, a specialist memory foundry. And they are integrating our technology into their next generation high bandwidth memory chip. There will be prototypes of that early next year, which will be validated, and then we hope that will turn into a commercial contract. So at that point, customers, initially on the edge computing side for IoT, would be able to buy that memory and incorporate it into their designs. We're also working with RISC-V processor manufacturers because the technology works better if it's in the processor as well as in the memory, but there are significant benefits if it's in either one or the other. But we've managed to speed up processing in a RISC-V processor by a factor of 57, and that's without having the modified memory attached. So that's another point on the roadmap. We're working with, as I said, a couple of RISC-V manufacturers, and we would hope to have a commercial launch on those next year as well.
Well, it sounds like super exciting technology. The Sustainable Engineering Alliance has spent quite a bit of time recently in data centers, looking at energy consumption and, as you say, cooling requirements. A lot of them are moving to a microgrid architecture, coming away from the national grid, going to solar power and wind power for a good percentage of their power supply. And so anything that can reduce energy consumption in operation, and also, more importantly, cooling, or just as importantly, cooling, is to be welcomed. So thank you very much, Helen, for explaining how all that works.
Thank you.
Right, we are now on the analog devices stand. I'm with Marcus and Jitesh. And what caught our eye as we came onto this stand was this particular application right here. We queried Analog about sustainability benefits of their products, and they honed straight in to this particular application, which is for the deployment of camera modules in automotive and other applications. So there's a really interesting sustainability angle here, because the technology involved in this is limiting the amount of material and weight in the wiring infrastructure required to carry that high-resolution video image back to the vehicle processing unit. So I'm now going to hand over to both Marcus and Jitesh to explain exactly how that works, how it differs from current architecture, and what the savings are in terms of material and weight.
So thank you. So here what we have is a GMSL technology, what we mean by Gigabit Multimedia Serial Link. It's a high-speed serializer, deserializer technology which allows you to conduct high-speed data in terms of up to 12 Gbps on the same cable along with your power. So in a forward direction, we can take up to 12 Gbps of data on a video or audio or even Ethernet. And we can transfer the power from your SoC or a compute module back to the camera. And along with that, what it also enables you to do is that it can aggregate 4 cameras on a single deserializer. That means you only need 5 total semiconductor parts to communicate with the 4 cameras, right? So overall, what it does is that it gives you a robust, high-speed, high-bandwidth data path for your machine vision and edge AI applications. As you rightly mentioned, in automotive industry and in non-automotive industry, like in industrial automation, where your total cable weight, where you have to carry not only the high-speed data but the power, it requires at least 2 pair of cables, right? Yeah. So instead of that, we can reduce the power cables, and that reduces the weight of the vehicle, and that also helps you in saving your CO2. And it also, when we have electrical vehicles, it also extends your EV range. So from the sustainability perspective, it does a lot of benefit out of the box. You don't have to do anything else.
The weight savings for a vehicle, we're into several kilograms of weight saving over previous architectures. And if we think about more and more vehicles now need more and more cameras and more automation and automated vehicles, so cameras are becoming a very familiar feature on a car. We have to be able to show new architectures that can massively reduce the weight, but also the manufacturing burden on the OEMs as well. These systems are much easier, much simpler to manufacture than the traditional architectures. We're also seeing applications in healthcare, so things like endoscopes could use this technology, where you need a very fine cable to go inside a patient, and also robotic systems, where we're seeing more and more vision systems on robots, which again, from a sustainability angle, more robots, more automation, we can increase throughput in manufacturing environments, but those robots do need vision systems to augment what they already do. Excellent. Thank you very much for that introduction to this technology. I think, having just returned from Cenex, where we were looking at the electrification of the vehicle fleet, and also where we were testing out some of the autonomous vehicles, which are camera dependent. I would imagine that this type of technology will find itself in those vehicles pretty soon. And as Marcus mentioned there, in terms of manufacturing simplicity, I'm wondering also about disassembly end of life. We're seeing new regulations moving in all time, particularly in automotive, in terms of the disassembly of vehicles at end of life and the recovery of valuable materials. So maybe by simplifying the way the cameras are communicating and simplifying the installation of the wiring infrastructure, that may also ease the disassembly and recycling of those materials. So we look forward to tracking this technology as it goes along, and maybe running some case studies for you guys soon. Right, we are now on the RAM Innovation stand, and I am with Peter, who is the General Manager. And as we were walking past this stand, what caught our eye was a reference to SWAP, which is all about size, weight, and power. Also references to reliability and ruggedness. And in the world of sustainable product design, all those things are super important. So we stopped by to take a look, and what we're looking at is a fascinating technology about embedded die for power module and power application design. And at that point, I'm going to hand over to Peter, who is going to talk us through what makes this technology different, and most importantly, what makes it better than the traditional methods of designing these types of products. So Peter, explain.
So simple, bare die. Right, bare die are small at the end of the day, but they are fragile. You put this in the application in the hands of an engineer, they'll break it. What we do is instead of using wire bonds to connect down to the bare die, we embed the die inside PCB materials. So you end up with a die, you end up with a package that is fully packaged here in my hands, what we call a pre-pack, with 2 GaN devices and gallium nitride devices. They can be silicon carbide, they can be silicon as well. But basically this is a superbly ruggedized package. There's no wire bonds to break, right? It's much smaller than a typical device. Typical devices look similar to these, TO247 devices or little white boxes that do power modules, which are all surface mounted and use wire bonds. Wire bonds are prone to breakage, so they're not ruggedized. This is obviously ruggedized. It's plated down to the die. It cannot break, right? So we've got a small device here, the same size as these 2 GaN devices here. These are the same thing, same device, much smaller, right? All these components are much closer together compared to these, which are on wire bonded out onto lead frames, meaning they have parasitic issues, which means they ring when switching at high speed. Ours are much closer together, much shorter lengths, therefore they don't ring. Therefore you're getting a higher efficiency improvements in each one of our devices. We can build multiple devices all at once, or we can build pairs of half bridges. We can do bi-directional switches, we can do half bridges, full bridges, the whole lot basically. The car industry loves it because obviously the efficiency that brings. Typical inverter leg, this is a typical inverter leg, 150 kilowatts in here of power in this sort of leg with 4 high, 4 low, SiC, right? These are GaN. It doesn't really matter. At the end of the day, improves the efficiency, hugely rugged. They put these through testing, vibration shock. Nothing's going to go wrong with that. There's no wires to break. The CTs all match, the thermal expansion is all matched on the material, so it won't break from that point of view.
And what other sectors outside of automotive would this be being used?
Renewables. So wind turbines all have inverters in it. Lots of houses now have inverters in them, right? They're hugely inefficient, really. There can be a lot more efficiency in these things, right? Yeah. At the end of the day, anything that uses power conversion. In our houses, how many power conversion devices do we have? Phones, everything, computers, televisions, all our power conversion devices. They are inefficient. They convert power from AC to DC, DC to AC, however you look at it. EV chargers, everything from that point of view, but also renewables. And we're seeing a lot of interest in the renewables. Wind farms, solar, all use inverters.
Okay. We're talking to a lot of companies here today that are discussing data center applications.
Absolutely. So data centers, everyone talks about AI. There's a lot of talk about AI and embedding in AI. That's the compute side of things, fine. It uses a lot of power. Those data centers use a lot of power. If you've ever been to see a data center, the UPS systems go on forever and ever out into the sky. They use a lot of power. Efficiency saving. This could say 1 to 2% efficiency per conversion. So, you're talking about millions of pounds being saved in unused energy. Right. Not being more efficient, not having more renewables, just not using the energy in the first place because of poor efficiency.
Okay. And for engineers who would be interested in exploring this, maybe they have a module at the moment designed using a traditional methodology. How do they migrate to this technology? What's the process involved?
So, you're not going to get hold of bare semiconductors, but we are. You're going to get hold of typical devices. We're making these small prefabs to make life easier for engineers. There's parasitics, there's modelling that's got into this, there's thermal modelling that's gone into it. We still need to get the heat out, creates a lot of heat in a small space. We work with lots of universities, and we have interns that come and work for us as well. And of course, we're trying to grow the industry. We need more people involved in semiconductor industry in the UK. We're really good at it, right? And we just need to grow that knowledge base, get people into STEM subjects and everything else. For us, we've designed these pre-packs so that engineers can pick up this easily and get on with it. They can mount this as a QFN on top of their board. They don't have to mount it inside their board. They can pick up these devices. So that's what the aim is when it comes to these ones. The issue when we come to bigger, more powerful devices like 1200 volt devices, obviously there still need to be pollution degree separation on the output power. So they're more bespoke units, But if you wanted to have full bridge, then we'd put 4 die in there. If you want a half bridge, it's 2 die. If you wanted 8 high, 8 low, to make an inverter leg, that's doable as well. It's more of a niche product, but you go.
And so you've got the design support within your organisation to help engineers migrate across to this as necessary.
And we'll work with you and the software package you're using to show you how to do an embedded design.
Okay. Yeah, brilliant. Right, I think that's everything covered. So thank you very much for that excellent explanation, and let's hope our audience buys into this technology and makes contact.
Absolutely.
Right, we are now on the SMD Semiconductor stand, and I am with Martin from weeteq, who is sharing space on this stand with an application. This is all about, how should we say, power management and control. What caught our eye initially was the technology Ultra Edge, shown on the panel here, looking at grid stability. So we came over to discuss that, only to discover that this is a more fundamental technology that can be applied across a number of sort of power management and control applications. So what I'm going to do is hand over to Martin, just to explain how these type of systems work prior to this technology, how this technology differs, and what the benefits to the end user would be. So Martin, please explain.
Sure. Yeah, so we do power and control system optimization, as you say. So this is all about an underlying technology which we call Ultra Edge. So you can think of this as the ability to be able to detect and respond to transients or error signals in less than 1/10 of a millisecond. So when you can do that and you can respond so quickly, you can start to come up with some really innovative use cases. One of them, as you say, is grid stabilization. So what we can do is we can work alongside a renewable energy source like solar and a battery source, or an energy source like a battery. And what we do is we provide that handshake between the grid, renewables, batteries, to be able to effectively provide what we call synthetic inertia to the grid. So instead of having a quite expensive flywheel to create inertia, which we had in the traditional energy sources with big turbines, etc., we're able to use microcontroller technologies to be able to facilitate that handshake between those systems. And effectively what we do then is the solar system acts as a benefit to the grid. So it provides a boost to the grid rather than being in protective mode and shutting down. And that's when we see these blackouts, when whole grids collapse in less than 5 seconds. So that's that side of things. We also do motor control applications for industrial applications, but also for automotive and any closed loop control system really. Focus on industrial control. This is all about our ability to be able to reduce stress on motors, but also be able to shave off these kind of peak current overshoots that we see in motors as they go through things like torque transitions. So we're able to kind of intercept when we see an inefficient transient happening, and we can choose a more efficient path. So it's about uptime of assets, it's about energy reduction, and also building systems with smaller components, so BOM costs for systems can ultimately be reduced.
So in industrial environments, you say motors, a lot of our audience are design engineers in the machine building type industry. So what you're talking about there is the speed of response is allowing you to sort of intercept those transient conditions. And when you say de-stressing a motor, I assume that might also mean improving its reliability and longevity, that type of thing, as well as being able to maybe downscale them. So saving material, saving weight, saving energy. Sounds like a fascinating technology. What would our audience need to do to get involved in this? If they like the sound of this and want to learn more, what's the roadmap? Is this available? Can they buy into this?
Yeah, so at the minute what we're doing is we're doing pilot projects. So we have a couple going on at the moment. This is one of them with SMD. We have others that are in the pipeline, and really is to validate the technology in customers' environments. So if people want to get involved, we can start from just one motor drive, and it's really low cost in terms of validating it. We've proved the technology out on various different microcontroller platforms. So depending on what they're using, we might have already done it, and so it's an easy process to do that. The website just got rebooted yesterday, so it's weeteq.com. It's got a lot more information about the different industries we support and the products that we'll be bringing to market, so people can take a look at that.
Excellent. Thank you. Sounds like a whole raft of sustainability-related benefits from this technology. So we'll be keeping an eye on this. Be in touch with you from time to time, see if there's some case studies coming out and some product news. So thank you very much for your time.